Okay, so for lesson 5, like I mentioned before, it's like a culmination point of why do we factor. Um, it's for solving equations for the most part, the second degree equations. And we're going to use this thing called the zero product law. Okay, so this may seem very, very simple at first, but it's important. So complete the following. The statement x minus 3 equals 0 is true only if x equals 3. You would just put this negative 3 on the other side as a positive and you have it. Or you just think to yourself, the only number that would make this 0 is 3 minus 3. So basically you're thinking like, what's the opposite of minus 3? It's a positive 3. So what's the opposite of the next one of a positive 1? Negative 1. And then now we have this next statement, which is a product. It says the statement x minus 3 multiplied by x plus 1 is 0. This is true if x equals, well, you just copy it down. It's the same. Okay. So for example, if x was positive 3, what would happen? You would put 3 minus 3, you'd get 0, and then you'd have 3 plus 1, which is 4, and 0 times 4 is 0. Now, if you use minus 1, you'd have minus 1 minus 3, which is minus 4, times minus 1 plus 1, which is 0. You'd have minus 4 times 0, which is 0. So basically, one of the terms has to be 0. And then both when you multiply. Obviously, when you multiply, if one of the things is 0, the whole thing will be 0. So this second one, we know one of them from this term. So x is minus 1. Now what's the other one going to be? Good. So x equals 0 goes with this one. And then x equals negative 1 goes with the other one. So that's basically what we're going to be doing. We are going to factor expressions. They're going to be factored. And then the other side of the equality is going to be 0. So this is the zero product law. Whenever you have a product, a times b, and it's equal to 0, I mean, either one of them is 0 or both of them is 0. Do you guys agree? So just put 0 on those blanks, and let's solve these very basic equations. This first one, 8 times something is 0. That something has to be 0. If you're not sure, divide by 8 on both sides. What's 0 groups of 8? 0, right? Now let's take a look at this next one. And I'll highlight it to compare. Look at 8x versus 8. Same or different? Different. So we're not going to have the x equals 0 option there. Do you see that? So sometimes students get confused by this. So if the coefficient, or basically the front, if it has an x on it, then you'll have x equals 0. But if the coefficient does not have an x on it, then you don't have x equals 0. It's not an option. So for this next one, you only have these two solutions. So when is x plus 2 equal to 0? When x is negative 2, good. And when is x minus 7 equals 0? When x is positive 7. Okay? So that preliminary step that I'm showing is not necessary. If you're good at this, let's just get the answer. So let's take a look at C. From this first term, what do you get? X 0. From the second one, you get negative 2. And from the last one, you get 7. So there's 3 solutions to this equation. 0, negative 2, and 7. And the last one, I'm going to do them longhand and then show you a pattern that you're going to want to commit to memory, because doing these longhand is sort of like a waste of time because it is very simple. So let's do the first one together. 2x plus 1 equals 0. Move the 1 over. You get positive 1 becoming negative 1. And then we divide by 2. So x is negative half. Okay, so I'm not going to do the second one. I'm going to show you the pattern. Use your hand or your finger and cover up that 2. What would the answer be for that first term? -1, right? Just like before, it's easy. What's the opposite of +1? It's -1. Move your hand away, and it's like, well, how do you get rid of a 2? Well, just divide it out. Okay, so let's try this one. Cover up the 3. What's the opposite of -2? +2. How do you get rid of a 3? Divide it out. So for this next one, it's going to be x equals 2/3. Now let's think about that as a substitution. 3 times 2/3 minus 2 is 0. Is that going to work? 3 comes in. What do you get? The 3's cancel. 2 minus 2. Oh, sorry, I screwed that up royally. I should have closed the bracket on that substitution. My bad. 3's cancel. 2 minus 2 is 0. Okay, so just one more time. Actually, we got lots to do, so we will show you some more in a bit. What is this E and F? Why is it acceptable to divide by 8 in A and B? It's acceptable to divide by 8 because this is just a product. It's a product equals a product, and then 0 on the other side. So I'm not sure what this is getting after. Why is it not acceptable to divide by x first in C? Good, because right now, this x here, if you divide it out, then you have 0 over x here. And the problem is, like, what if x is 0? You can't have that. You can't be dividing by 0. To be honest, I've never ever seen E and F, so I was like, most students wouldn't do that. I've never really seen that, so let's almost just ignore E and F. Okay, so all the above equations are polynomial, and it's where the other side is 0. So basically you have some polynomial p of x and it equals 0. And then we want to find the solution, and the solution basically is like, okay, which x satisfy 0? Which x is going to make this polynomial 0? And then what it ends up looking like in the graph, say you have some function, something like this. This is some function. We're trying to solve for like where it's 0. We're looking for these spots here. So this is what we're actually doing. These are called x-intercepts, and another word for this is zeros. So this is basically what we're trying to get after. Where is this polynomial 0? So which x values make this polynomial 0? Which x values make the polynomial 0? And they're called x-intercepts or zeros. Any questions on that? Those functions can look like anything. They're just these polynomials. In grade 10, you're used to like just a straight line. In this course, you're going to learn the U-shaped. This is for like a math 30. This is a third degree polynomial. There's fourth degrees, and there might be 4 curves in them, and there's like infinite amount of the way these things look like. Okay, but we're just focusing on solving these quadratics. So this is going to be degree 2 only. So for solving quadratics, let's take a look at this degree 2 polynomial right here. You can see this degree 2 polynomial, this p of x, is equal to some 0. And we're saying, okay, which x values make this true? Guess what the first step is? Yeah, and for the most part, they're going to give you equations that can be factored so that you can model this process. If you can't factor it, we'll show you other strategies. There's a formula that you can use, and of course you can use technology. Pretty simple. Okay, so what are the two magic numbers here for 20? 5 and 4. Which one's negative? Both? Good. And it even gave you these minuses. So they're going to show you the intermediate step where they're like, okay, well, this term has to be 0, therefore x is 4. This term has to be 0, therefore x is 5. Now this step here can be skipped. So you can skip that step. Okay, so the solutions are 4 and 5, or you can write it like x1 comma 2 are 4 and 5. Mostly I would do this. x1 is 4 comma x2 is 5. That's what I would do. You know, you have two solutions. If you had 3, you'd put x1, x2, x3. So there's two solutions, x1 and x2. Doesn't matter what order you put it in. 5 could have been x1, does not matter. So let's take a look at this first one. It's a very simple difference of squares. So what's it going to be? X minus 9 and a plus 9 equals 0. Therefore, the two solutions are 9 and minus 9. And because it's the same number, you can do this. Plus or minus 9. So the two solutions, x1 and 2, are plus and minus 9. Any questions on this? Sort of just whipping through it. This stuff is, once you get used to it, this stuff's very, very easy, but you're going to be doing it a lot. You're going to use this actually a lot. When you get to Math 30, you're going to be solving equations all the time. Often they end up being quadratic. So like in junior high in Math 10, you're solving like these linear equations like ax plus b equals 0. Typically you put the constant on the other side and then you divide out the coefficient. Eventually, like this is degree 1. This is how you solve an equation when the powers are 1. So when the powers are 2, this is how we solve the equations. So when powers are 2, we make the other side 0. And then we figure out which x values make that happen. And that's how we solve degree 2 polynomials. So let's take a look at this next one here. Difference of squares again. So what is it going to be? 2x plus, almost went put 9. 2x plus 3 and a 2x minus 3 for this equation here, and it's equal to 0. Okay, so do we need to do this one by hand, or are we going to use a trick? Okay, let me use a shape. Maybe if I could use a shape to cover it up. Didn't work. Okay, I'll just use my pointer. Maybe the pointer will work. Doesn't work. What if I just scratch it out? What if that 2 wasn't there? What would be the answer to that? Negative 3. But the 2 is there, so it's negative 3 over 2. And this one's identical, right? But different sign? So what's going to work on this one? 3 over 2, right? Because then the 2's would cancel and 3 minus 3 is 0. So the answer for this one is just, okay, Mr. Al, let's do this. Okay, plus or minus 3 over 2. This is what we're looking for in the purple. Plus or minus 3 halves. So what you're coming to realize is that these difference of squares, what do you notice with these difference of squares? When you go to solve them, they always have the same answer, but different sign. So this next one has a GCF. What is it? 10x. Take it out, you get x minus 9. Okay. The second one's very easy. What is it? 9. Now this first one, whenever you have a monomial, because the binomials are quite easy, it's just the opposite. And if there's a coefficient here, just do it, and then if it wasn't there, whatever, we talked about that. But for the monomials, if it has an x, it's very, very easy to memorize x0. Now I just want to warn you, if there's no x on there, don't put this. If there's no x there, do not put this. Okay, and this one's going to be a little bit different because there's no x this time. Take out the 10 and you get x squared minus 9. And I love that they put this question right next to it because it's doing exactly what I just warned about. So the next layer of this factoring would be x plus 3 and x minus 3. Everyone's seen that one lots. Okay, so from the first term, 10, there's no x there, so there's nothing about x0. You don't have to worry about that one. You just have this one and this one, negative 3 and positive 3. So the solutions for x1 and x2 are plus and minus 3. So the comment was that these questions are pretty easy. Do you guys agree? Yeah. The only way that they get hard is that if the expression's hard to factor. And then once you get down to this stuff, you got to make sure you finish it off. So these next class example 3, we just have to factor them. So this AC value is negative 30. And then the B term is negative 13. What's going to work for that? 10 and 3 or 15 and 2, right? I don't know which one. They both seem to work. So which one could work? I love the thinking. This helps a lot. What does the negative product tell me? That one has to be positive and the other has to be negative. So that won't work for this one. These ones both have to be negative for that to work. So it's not those ones. So this one's negative and this one's positive. Okay, so excuse me. 3x squared, we've got a minus 15x and a positive 2x and a minus 10. Throw them in groups. Coming out of the first group is 3x, you get x minus 5. Take out a 2, a positive 2, you get x minus 5. Take out the common binomial, x minus 5, you have 3x plus 2. And then finish it off. X equals 5. And then this last one, don't yell it out, please. Let people think about the last one. Don't yell it out. Come on, don't whisper it either. So for sure it's going to have a negative 2. And we have to divide out. Okay, good. Just give people a chance to do it on their own. There's the two answers. Now jump to the next one. What's weird with the next one? Doesn't equal 0. Good. So make equal to 0. So we have that 25 coming over to the left. Could you have put the 5 and the 30 term to the other side as well? Yeah, you could have, but then everything would have been negative, and that's just bizarre to me. So make things easier for you, and in order to make things easier, I always have this first term, the lead term, positive. That's my convention. My brain almost just shuts down if this first one's negative. I just hate it. I always keep this first one positive. So if this was negative on the left here, I'd move all this crap to the right to make this first term positive, because that's what I'm used to. This one's obvious. Factoring flowchart. What's the very first thing? Factoring flowchart, you guys. Don't forget, or else it makes your life hard. You're doing all this good math, but you forgot the very first thing. Okay, so take out your 5. And then it's becoming inspection, so it's like, this is such a breeze. Is there one that works for this? Yeah, because 5 is prime. Your only options are 1 and 5. You double check, does that add to 6? It does, so you're good. X plus 1, x plus 5. Okay, so do I have an answer from the first term 5? There's no x, so there's no answer from the first term. The second term has an answer and the third term has an answer. They are -1 and -5. Good job, you guys. So I guess homework's 1 to 4, and then there's probably like a silly word problem next. Oh, there's 2 word problems. So step 1, introduce a variable. Step 2, form a quadratic. Step 3, solve the quadratic. Step 4, state the solution. Oh, thanks, tips. Like, what else would you do there, right? Anyways, this is a good book. I'm not trying to be sarcastic, but this is a good book. I don't want to give it a wrong impression. Class example 4. The area of a rectangular sheet is 300. So what can we write there? Area of a rectangle. So maybe area rec equals, because that's what is, right? Every time you see is, put equals, and then you can put 300. So let's just use the area formula for rectangle. Length times width, but let's just use x times y. So length times width, x times y. And let's just even draw in a little rectangle here. Right next to it, x and y. You guys okay with that? Rather than using L and W, we're used to x and y. Let's just use x and y. And we've got the first set of information done. And these word problems that you see on standardized exams, you have to get good at them. In Alberta, anyway. If you were in Finland, you wouldn't have to. They don't do multiple choice exams in Finland. So yeah, crazy, right? Anyways, we're in Alberta. We have to do this. What? They do, I guess, I don't know what it looks like, but I guess it's different. And they do quite well over there. So anyways, basically, I'm trying to give you some techniques to handle word problems. You got the first statement handled. There's nothing else to that first statement. Do you agree? It's handled. We've done it properly. This is called modeling modeling a problem. Now the next one, what do we have here? Some length. The length. Which one are we calling the length? Sure. Hey, don't try to rock the boat here with y, buddy. We're using x. Okay, the length, x, the length, so x, right, the length is, so what is? Equals, and then it says 5 more than the width. Crazy? Okay, so then it says form a polynomial equation and solve it to determine the perimeter. All right, that's bizarre to me. But this first thing, forming this and solving it, is bizarre to me, but I can handle this. Perimeter is what? 2 x's and 2 y's. Okay, do I know what y is? Kind of. Do I know what x is? Kind of. Okay. But I'm thinking they want me to form a polynomial equation, so that would be like p of x. But the problem is, I have y here. So let's get rid of y using the area. I know that y, if I move this 5 to the other side, x minus 5 equals y. And I'm thinking I'm going to do a substitution with this y and this y here, because then I'm going to form a quadratic. So x is x, and then y is x minus 5, and all that is equal to 300. Can I solve that? No. I got to move the 300. So let's distribute this in. You get x squared minus 5x, and then I'll subtract the 300 to the left, and I'll have this. Can I factor that guy? What multiplies to 300? 60 times 5? That's not going to work because it's not going to get you to 5. Guessing and checking, guessing and checking. How do you guess and check? Do you want me to show that? Okay, guessing and checking for factors of 300. Hey, don't give it away. I want to think too. I just want to show you guys how to guess and check. So just guessing and checking. 300 divided by 2, that's not going to work. Divided by 3, that's not going to work. I just wanted to show so people don't feel like they're lost. That's not going to work. Got it? Thank you, Ashwin. So it's 15 and 20, and which one's negative? And it's inspection, so it's quite easy. So x, 15, and 20. Which one's negative? Negative 20 and positive 15, and this is equal to 0. So what are the solutions to this equation? X equals negative 15 and x equals 20. Now I'm just going to give you a little heads up. One of those answers doesn't make any sense. Which one? Why doesn't it make sense there, Daoud? Can a length be negative? Can this length be negative? No. So we're going to reject that answer and go with 20. This is the solution for x. The other one has been rejected. It is a discrimination against negatives, isn't it? Negative length. Doesn't make any sense. It's like going into the paper or something. Or into the, I don't know. It's like you need another dimension or something. Okay, so if we know that x is 20, what could we do? Put it right there, and we'll get y. So we can scratch this out because we don't need that x. We're just going to solve for the perimeter. So it's 2 times x, which is 2 times 20. And then if I put 20 up here, minus 5, I got that 15 is y. So it's got a 40 plus a 30, and the perimeter is 70, looks like centimeters. Any questions on how I finished that off? Well, there's probably another question just like it in the homework. Yeah, in the homework, it's number 5. You'll have something very similar. Okay. Okay. One more example, and then you guys are free of me. Okay, so the next one is a very challenging word problem. No. Yep. So this next one is very challenging because you have to have a very good understanding of geometry to do this question. We have this cross section of a water trough. This is like what farm animals would put their faces in and drink water out of. You guys know what a trough is? Imagine an animal here, like draw a pig. So he's going to put his face in there and drink some water. Okay, so let's take a look at this problem. So they've given us this 45 degree to the horizontal, and they've also given us this 90 here. Okay. So what does that mean this angle is down here? How do you know that? Because if this is 90 and this is 45, the only angles left is 45. You can subtract from 180 to realize that. Now, what type of triangle has two angles that are the same? Isosceles. So if this is x, this segment here is also x. So that's also x. Now that's tough. I mean, I just gave it to you for free. If I threw this down on an exam, I don't know how many of you would be able to spot that. It's challenging. So now, what do we have going on here? The diagram shows the trough, blah, blah, blah. The length of the whole thing is 36. Okay. Show that the area of the cross section is x 36 minus x in a product there. Okay, so how would we do the area of this? I'm thinking there's 3 shapes. And 2 of them are the same. So it's like A1 is the same as A1. Do you agree? Okay, could we find A1 pretty easily? What's the area of a triangle? A half AB. Base times height, or altitude times base, whatever you want to call it. So in this case, it's a half times, what's A? X, and what's B? X, right? A is X, or, sorry, let's do it this way. B is X, and A is also X. So it's just a half X squared, right? And how many A1 shapes are there? 2. So let's double this. Let's times this by 2. That looks very confusing with an X in there. So let's double this. Let's times by 2, and you get X squared. Do you agree? The 2 and this 2 will cancel? Okay, so for the two triangles, it's just X squared. Now, we also have to do this rectangle here. Let's call this A2. And the formula for A2 is just a rectangle, so LW. What's L? I don't know what L is. What's W? X, right? So all we need to do is find out what L is. Anybody want to hazard a guess what L is? The whole length of the trough is 36, but you're going to remove X twice. So this formula for this would be 36 taking away, no, 2X. Because we're going to remove this piece and we're going to remove this piece. So you've removed X twice. So this like teal piece is 36 minus 2X. Okay. So let's expand that. We have 36x minus 2x squared. Now we need to add up the 2a1. So the 2a1 was x squared plus a2, 36x minus 2x squared. And what does this become? We're just adding all the areas up. 1x and minus 2x makes 36x minus x squared. Factor out x, and you get 36 minus x. So did we do what they wanted? Show that this is this. Okay, we've done that. And you're like, wow, that was an awesome endeavor, right? Not useless. Awesome. Come on, positive thinking. No, that's a scribble proof. Okay, next one. If the area of the cross section is 260, determine x. So what was the area? X minus, oh sorry, x and then 36 minus x, right? That's the area? And it equals 260? Okay, multiply this in, and then we're going to have to refactor. Bring the 260 over because it has to be equal to 0. This is my biggest pet peeve with factoring. A negative lead coefficient, so I'm going to bring all these things over to the right there because that's a personal thing. So I'll put the x squared, a minus 36x, and a positive 260. Just rearranging it, making sure I'm comfortable with sign. Now it's easier for me. Now I'm guessing and checking 260. 26 times 10. Oh, that was easy. That was an easy one because it ends in 10. So x minus 26 and x minus 10. Okay, so we have x equals 26 or x equals 10. Now we need to just check the validity of these answers. So that middle segment, do you remember that middle segment was 36 minus 2x? Well, if you put a 26 in there, you end up with a negative length, which is impossible. So we have to reject that. A negative length is impossible. So this 26 gets rejected. Kind of like sometimes in high school, kids get rejected. Sad, right? It happens to adults too. Even the little kids. Everywhere, people's getting rejected. It's so sad. I don't know. I'm not there to see. But everybody knows what this feels like, and even the number 26 now knows what it feels like to be rejected. Yeah, 10's special, eh? Okay, so the math word for this, instead of saying reject, is, you ready for this? So extra. No, I'm kidding. It's extraneous. You thought it was extra, didn't you? Yeah, so if you don't want to use that word, that's fine, but that's the proper word. It's an extraneous root, which you do not need to worry about. Just use 10, so x is 10. That's the answer, okay? So you have whatever's time left, 15 minutes or whatever, and you're going to try your hardest on all these. I would do all of one just to get used to it. I would do all of one. And then 2 looks pretty easy. So do all of 2. And then when we get to 3, three is where, you know, it gets real. So do all of them. This is the real stuff. You know, like when you're working out and you do like 5 or 10 sit-ups and you don't really feel any pain? That's like parts 1 and 2. And then you know when you're like doing the 10th, 15th, 20th sit-up and it really hurts? And it's really that's where it counts, because that's when you're actually doing stuff. That's number 3. So this is the painful part. And then I would say do 4. 4 is like similar to 3. I don't know why they just didn't keep that all one question. And then 5 is your word problem, similar to what we did. 6 is going to be challenging because it goes back to Unit 1. So I'll leave 6 as a nice review. Only the brightest will get this one. The best and brightest. Okay, so if you could get 5 done, I'd be very happy. If 6 doesn't get done, I'll be sad. Maybe you won't be, but I will be. 7 is like 5, so maybe do 5 and 7. And if you really feel like skipping stuff, don't do 6. And then it's into the multiple choice and the numerics. So make sure 3 gets done. 1 and 2 is easy. Fast.